Start a new Blender session or reload startup scene from File, New, General. In this part, we'll set up lights, create materials, and compare render engines. Blender comes with 3 render engines, which are based on different principles and produce different looking images. Workbench is for modeling process, Eevee is suited for real-time rendering, and Cycles renders the highest quality images. Third-party renderers can also be plugged in. Note that in general changing renderers is an export-import process, after which materials and lights need to be modified. Eevee and Cycles are matched together, so that most lights and materials are compatible. The default layout workspace has viewport shading set to solid. In this mode, scene lighting is preset, and the lights created for the scene have no effect. In Outliner window, hide the default cube by clicking its eye icon. Press Shift-A to add Mesh, Monkey. This is Blender's mascot Suzanne. Press 0 from the numpad to get the camera view. From Properties window, Modifier, add Subdivision Surface Modifier. Right-click Monkey and set Shading to Smooth. Rotate Suzanne around Z-axis by pressing R, then Z, type 45 by using the number keys on top of the keyboard, then hit Enter, so that she now faces the camera. Add Mesh, Plane. Scale it up by pressing S5 and Enter. Move downwards 1 unit by pressing G, Z, -1 and Enter. Add Mesh, UV Sphere. Add Subdivision Surface Modifier by using shortcut Ctrl+1. Right-click the sphere and shade it smooth. Move the sphere left by pressing G and then Shift-Z, so that sphere stays on the plane. Then click the left mouse button to release the sphere. Duplicate the sphere and move it to right by pressing Shift-D, then Shift-Z, and click the left mouse button when the sphere is on the right-hand side of Suzanne. In Viewport Shading Options, choose Color, Random. This concludes Viewport Shading, Solid, Workbench Renderer. Now we'll look at the other shading modes. Change Workspace to Shading. This defaults to Viewport Shading, Material Preview. Eevee Renderer is now in use. We'll address the lighting next, so change the viewport options to Scene Lights and Scene World. Now we can see the light that is shining from the lamp objects that are created for the scene. We will create 3-point lighting set next. Select the light object and change its name by double-clicking an outliner to light.key. From Properties panel, Object Data, which is displayed by bulb icon, change light type from point light to area light, and change its power to 700 watts. Go to Top Orthographic View by pressing 7 from the numpad. Duplicate the light by Shift-D, while moving it down and right, so that it ends up roughly on the Y-axis near the plane edge. Grab the yellow dot on the light line and move it to Suzanne's forehead, so that also the duplicated light shines on the monkey. Name the light light.fill. Lower its power to 200 watts. Duplicate the light once more and move it to the backside of the monkey, about 1 monkey head distance from Suzanne. Grab the yellow dot and place it on the back of Suzanne's head. Name it light.rim. Enhance its power to 1000 watts. Press 0 for the camera view. Now you have the classical Hollywood-style 3-point lighting setup. Now it is time to add materials to the objects. Select the monkey. In the Shader Editor window, click New. Edit the default general-purpose material, Principled BSDF, by choosing subsurface value 0.8. The default subsurface radius RGB value is a reddish color, so the monkey head shows reddish fleshy tones originating below the skin surface. Select the sphere on the right and click for New Material, with Metallic 1.0 and Roughness 0.1. Note the reflections of the three lights, and the gray background on the sphere surface. For the sphere on the left, click New, and lower the base color white, from 0.9 to 0.6. Press Shift-A to add a vector, displacement. Also add texture, noise texture. Connect noise texture's upper output to displacement's height input. Then connect displacement's output to material output's corresponding input. Increase noise texture detail to 5 to increase fine structure on the bumps. Select the plane and create new material. Add texture, checker texture node. Connect its color output to principal BSFD's base color. From the top left of the shader editor window, switch from object to world. Add texture, environment texture. Click Open and navigate to Blender Portable folder, Data Files, Studio Lights, World, and choose Night.exe. Connect texture's color output to background's color input. Note how the image is reflected by the metallic sphere. Switch back from World to Object in the Shader Editor window. Make the cube visible by clicking Outliner's icon. Select the cube and change Transmission to 1 and Roughness to 0. Note that no transparency is shown, due to Eevee Renderer's default settings. Adjust Eevee to include reflections, transparency, and translucency as follows. In Render Properties, tick Screen Space Reflections, and under it tick Refraction. Glass cube still selected, go to Material Properties, Settings, and tick Screen Space Refraction. Now the cube becomes transparent. Select Suzanne. Tick Material Properties, Settings, Subsurface Translucency. Note the difference in monkey ears. Lower the camera angle slightly for better reflections. While cursor is at the 3D viewport window, hit N to open side panel, click View tab, and tick Lock Camera to View. When locked, a red line appears in camera view around the camera passepartout. We will assign a shortcut key for this. Right-click Lock Camera to View to assign shortcut and press F5 key. In the camera view, rotate the camera by using the middle mouse button. When ready, remember to unlock the view by using the assigned shortcut F5. Now we will switch from Eevee Renderer to Cycles Renderer. Cycles is slower but produces more realistic looking images. Select Viewport Shading Rendered. From Properties, Render, Render Engine, choose Cycles. Reflections, refractions and transparency become more realistic, but are rendered slower and with noise. In particular, the appearance of Suzanne inside the glass cube is noisy. Next we'll fine-tune the materials. For the plane, change roughness to 0.1 and make both checker colors much darker to show reflections better. Select the bumpy sphere on the left, go to Properties, Material. Scroll down to Settings. Change Surface Displacement from Bump Only to Displacement Only. You might have to click the eye icon off and on to refresh the view. Note that the bumps become part of the geometry. Make the best of the two worlds by using displacement and bump. Notice how displacement bump detail increases when cranking up subsurface modifier subdivisions value, but beware that high polygon count slows computer down and can potentially crash Blender. Last, we'll revisit the glass cube material. If render time is not an issue, say when rendering overnight, the material is fine as it is. Long render times are needed to get rid of the noise caused by caustics, which are not handled well in cycles. The following trick makes rendering faster on the expense of realism. From Properties, Render, Light Paths, Caustics, turn caustics off. Note how this makes objects that are enclosed by glass very dark because of the shadow thrown by the glass. The simplest solution is to disable shadows for the cube. Shadow visibility is available in Properties, Object, Visibility, Ray Visibility, Shadow tick box. To render the final image, choose from File menu, Render, Render Image. Shortcut is Function key 12. The image gets rendered in its own window. Render settings and output settings can be adjusted from Properties panels. You can render several images to different slots and compare them. Note that the image is not saved until you choose Image, Save.